Okay. Hello and welcome to those of you joining us today for our joint webinar with Buoyant. Today we'll be introducing the basics of GitOps and progressive delivery and showcasing how to implement both using GitOps, Flagger and Linkerd. But first, before we begin, I'd like to mention just a few housekeeping items. Next slide, please, Stefan. Today's webinar is being recorded and we'll share the recording with you and the slides tomorrow. All participants are currently in listen-only mode, so if you'd like to ask a question, please use the Q&A panel at the bottom of your Zoom menu, and we'll address those during the Q&A portion of the webinar. And with that, I'd like to introduce you to our speakers today. Next slide, please. We've got Stefan Prodan, who's a principal engineer from Weaveworks. Stefan is also an open source contributor to cloud-native projects like Flux, Flagger, Service Mesh Interface, and others. He's worked as a software architect and DevOps consultant, helping companies embrace DevOps and the SRE movement. Stefan has over 15 years of experience with software development, and he enjoys programming in Go and writing about distributed systems. And then we'd like to welcome Flynn, who's a technical evangelist at Buoyant, where he educates developers about the Linkerd Service Mesh, Kubernetes, and general cloud-native development. He spent nearly 4 decades in software engineering from the kernel up through distributed applications with a common thread of communications and security throughout. Flynn is also the original author and maintainer of the Emissary Ingress API Gateway, and you can find him using @Flynn on the CNCF or Linkerd Slack channels. And now I'll hand you over to Stefan to begin.
Hi, folks. Great to be here. Hi, Flynn.
Hey, thanks for having me.
Sure. We'll go through the agenda. So we are going to explain a little bit what GitOps is, what a service mesh is. We are going to do an introduction to Linkerd, Flux with GitOps, Flagger, all the tools that we are going to use. And of course, we are going to explain what progressive delivery is and how you can achieve progressive delivery on your Kubernetes clusters, combining all these technologies together with GitOps, Linkerd, and all the other tools. And finally, I'm going to do a demo, a live demo on a cluster, and we are going to see how all of this, works together. And finally, if you have any questions for the demo or everything that we will be talking about, please write them down and we'll try to answer. Okay, so what is GitOps? I like to explain GitOps to people that are accustomed to Kubernetes as a way of replacing imperative functions, like, you want to install something, you do a Helm install. You want to upgrade something, you do a Helm upgrade. Or you want to create, namespaces, Kubernetes users, and so on, you'll do a kubectl apply. Or if you want to change something, you'll do a kubectl edit and so on. Right? What GitOps tries to do is, instead of using CLI tools to perform actions on your production clusters, you'll use Git and a Git repository, one or more Git repositories. The gist around this is that because Kubernetes by nature is a declarative system, instead of reaching out to Kubernetes, we can extend the cluster to observe its desired state outside and conform to it on its own without us having to go every time, connect to the cluster from our machines or from CI to change something. So the idea is that Git is the single source of truth for everything that happens on your clusters. And if you want to do a modification, you'll do a Git commit, a Git push, and then things will just happen. Now, CNCF has a GitOps working group made out of several organizations and interested people, and they come up with a set of GitOps principles that not only Flux, the tool that I am working on, but also others, Argo, Jenkins X, and there are so many other tools in this space. All of them try to subscribe to these principles. And these are, first, you need, for a system to be managed by GitOps, you need to have this desired state expressed declaratively. And what this means for Kubernetes is you have YAMLs in a Git repo. Now, the second one is desired state is stored in a way that enforces immutability, versioning, and it retains complete version history. Well, that's a fancy way of saying, you know, you have a Git repo. Every time you do a change, you do a Git commit, a Git push. If you want to see all the things that happen on that repo, you do a Git history. Now, of course, you can cheat. You can do a Git force, you can override the history, but those are, let's say, Git issues. We can do protected branches. We have tools to enforce a complete version history like this principle describes. And on the server side, we have the software agents that automatically pull the desired state. So this is a difference that I'll be getting into details later on. The idea is that something runs on the cluster and that something connects to Git. You don't use CI or some other tool to do the other way around. And finally, a very important aspect of GitOps is that when something changes, you apply the change. But what if someone goes behind the scenes, connects to the cluster, and does a change on the cluster? The software agent, in our case Flux, should continuously observe and compare the two states. And if there is a drift, it should correct that drift. If you do a kubectl edit on your cluster for production deployment, and you change that outside of your pipeline, the software agent should correct that and alert around that modification. Last slide about GitOps. Here, what we are trying to explain is that there are like two separate things. There is the continuous integration part where, of course, you change code to your application, you build the code, you test the code, and so on. And on the other side is the continuous delivery part driven by Kubernetes and the GitOps agents, which are helping you to manage the workloads on a cluster. This is the operational aspect. How it does that through deployments, not only of applications, but also of the clusters themselves and all the things that depend on, you know, on setting up the production cluster. Even if you run these controllers on Kubernetes, this doesn't mean the controllers only change the cluster of Kubernetes itself. For example, you could, you know, have Terraform controller that runs there and that can provision, I don't know, databases, S3 buckets, whatever your application is, even outside Kubernetes. So the operating model for cloud native is not only about Kubernetes, it's everything that encompasses how your app runs in a production cluster. So to resume, Git is the single source of truth of your desired state across clusters, across workloads. All intended operations are committed by pull request. This is a great aspect that we can apply from development also to operations. Like when we do code development, we change something in our source code, then we create a pull request for our peers to review and approve it. We can, adopting GitOps, we can apply the same approval workflow to any infrastructure changes. Maybe I'm, you know, making some mistakes. Maybe I'm opening a port that I shouldn't be. So my SRE peers in my team should, you know, approve, verify, maybe suggest changes, security improvements before I'm making the actual change on a production system. Now, every time you merge a pull request, the cluster itself should automatically reconcile that change. And if something fails, it should, you know, revert it. It's like a transaction with a database, right? If you change 10 deployments and you have something funny there that doesn't really work on Kubernetes, in one deployment, those 10 changes shouldn't be applied at all because, you know, there's the idea of having a transactional model applied to your production systems. And finally, very important aspect is all changes are observable and verifiable and auditable. Observable because the agent running on the cluster will tell you what's going on with change, how the change was applied. Verifiable through commit signing, and so on. And auditable is the idea that you don't have to look at the cluster to determine what's there. You can just look at the Git history and see how all these changes were made on your production systems. So that's it about GitOps. We'll talk more about it later. Let's see what the service mesh is. Go, Flynn.
Thank you. Service meshes are simpler than GitOps, actually. You go ahead to the next slide, please. So a service mesh is basically an infrastructure piece that you put into your cluster. It provides security, reliability, and observability uniformly across your entire application without requiring you to change your application. This is a pretty big deal. You can have your application already running. You can put a mesh into it, basically slide the mesh underneath your application. And without actually having to go through and change things, you suddenly will start seeing improved security, better reliability, better observability, in a lot of cases without even having to configure things. It's also nice because it gives you a way of separating concerns and allowing your applications team to worry about the application while you're allowing your platform team to worry about the mesh itself. Next slide, please. The way this works, if you imagine your typical Kubernetes-based cloud-native application here, you'll have a cluster, you'll have some services in the cluster, and then all the services will end up needing to talk to each other, right? If we go on one more slide, most service meshes, notably including Linkerd, work by putting user space proxies next to each of the applications pods, and then allowing those proxies to intercept communications between the workloads, so they can end up mediating and also measuring all of the traffic happening anywhere within the application, whether it's out at the edge or all the way very, very deep in the call graph. Collectively, those proxies we call the data plane because they are the things that worry about moving data around. There's also a control plane, which is a set of processes that are managing all the proxies so it can do the right thing. That's actually kind of it for the service mesh itself. Yeah, go ahead. What we're going to show today is a little bit more complex. We're going to be talking about GitOps as a whole, and we're going to do GitOps using Weave GitOps and Flux and Flagger and Linkerd. And so we're going to show how all of these things fit together. If we can go on to the next slide, let's talk a little bit about Linkerd. One more. Linkerd is currently the only CNCF graduated service mesh. We've been in production for a long time. We've got a lot of GitHub stars. We've got a lot of funky logos. One more slide. This is the most important thing that I'd like everybody to take away about Linkerd from our shock and awe slide here. Linkerd is a service mesh. Linkerd's purpose in life is to give every developer all of the tools that they need to create secure, reliable, observable cloud-native applications. And Linkerd is trying to make these tools very widely available at no cost. We typically think this is a pretty good goal. All the logos behind this agreed with us that it was a good goal. And with any luck, by the time we're through with talking about how you can use it in a GitOps world, then you'll agree too. So that's actually it for Linkerd. Stefan, back over to you to talk about how we're going to put all this stuff together with Weaveworks and GitOps and all of that. Thanks.
Sure. Thanks, Lynn. Okay, so some words about Weaveworks. We invented the idea of, the term of GitOps while developing a tool called Flux. This tool was made initially inside Weaveworks to help us, accelerate our delivery. We were back then an early adopters of Kubernetes, and we were offering Prometheus as a service. Prometheus was also very young. So we were trying to, create this open source project that will allow us to scale Prometheus, which is called now Cortex, is a project started by Weaveworks, now is maintained also by Grafana and is in CNCF. So GitOps came into being after our CEO Alexis observed what Flux is doing, and he came out with this term. Besides Flux, Weaveworks is highly involved into open source. Most of our projects have been donated to Weaveworks or to CNCF or are available on GitHub as open source. We also collaborate with cloud vendors. We created EKS, Cattle, and so on. Let's talk a little bit about Flux. So Flux is a CNCF project like Linkerd, a graduated project. It graduated last year in November. And what's the scope of Flux? Flux tries to, offer you a complete continuous delivery platform. Built on top of Kubernetes, supports all the common practices and tools in the fields. I think one of the drives Flux and why Flux is successful today was the fact that we made Flux play nice with all the other projects in the cloud native space, not only the CNCF projects, but almost everything on the CNCF landscape can be managed in some way or integrated with Flux. And Flux is now at version 2, same as Linkerd. We went through a major override Flux, major rewrite. And now Flux is powered by a thing called the GitOps toolkit, which is a composition of Kubernetes APIs, controllers, and so on. The idea is that Flux tries to, make continuous delivery using the GitOps principle, easy to adopt and drive at scale. Another project under the Flux organization, the Flux CD, is called Flagger. Flagger is the operator, the Kubernetes operator responsible for progressive delivery. And what Flagger does, it basically decouples the deployment of an app from the release process. If Flux does the deployment, then from there, Flagger takes it on and does this progressive traffic shifting. And we'll talk a little bit about Flagger later on. What's with GitOps? With GitOps is a product made by Weaveworks. It has an open source edition and an enterprise edition. The open source edition is a web dashboard for Flux, where you can see everything that's happening on your cluster. You can monitor what Flux is doing, debugging it, see the health check, the health status of your apps, of Flux itself, and all the other components. The enterprise edition is a little more advanced. It comes with cluster fleet management built on top of Kubernetes cluster API. You can drive multi-tenancy through self-service. It comes with templates, profiles, policy of code. And one important feature that I like the most about the enterprise edition is that it gives you an easy way of automating how a app change goes from one cluster to another, right? So it does a rollout throughout your environments from dev to staging to production with a nice UI where you can observe all these things. And there are many other features of GitOps Enterprise. I did the link here if you are interested in it. Okay, so I'm going to explain how we got to progressive delivery. So here is a diagram of how CI/CD looks like in a canonical way, how we used to do it, right? You have your app code, app manifest, maybe infrastructure manifest like the Linkerd definitions and so on. They are in your repository. You make a change to your app, then the CI/CD process kicks in. Maybe you have a Jenkins or GitHub Actions or whatever. The idea is you have to, build your app, put your app on a container registry, then change the YAML. So, you have the new app version in there, connect to your clusters from the CI runner and apply those YAMLs or do a Helm upgrade directly from your CI job. While this approach works very well, it has a lot of security issues. For example, what we've seen in the last years is that large organizations got hacked by, by people that got in their CI systems, and there they found all the keys, right? If you build your software, if you deploy your software from the same thing, which is running outside the cluster, of course, and that thing is vulnerable to something. Let's say you download a package, an Node.js package, which has some things in it, or you forget to set up a good password for your Jenkins UI, or you install Jenkins without a password because that's the default, right? And someone finds the URL. All of a sudden they have the keys to the whole kingdom, because for your CI system to be able to deploy changes to Kubernetes, that means you have a kubeconfig in there available to anyone, right? So by entering the CI system, the hacker does not only have access to your source code, has access to your production clusters as well, and can deploy there anything, like, I don't know, Bitcoin miner or whatever. Or even worse, it can spy on you, and I don't know, how are you going to be aware of that? It's very hard, right? So one change that comes with the GitOps idea, instead of doing this imperative deployment, we switch to a declarative pull-based pipeline, where there is no process that runs when you do a Git commit. Instead, the clusters themselves, they are connecting to your Git repo. They monitor the Git repo through a software agent, in our case, Flux. And when the software agent detects a change in the cluster, it tries to reconcile it. When the change is detected in the repo, it tries to reconcile it on the cluster. So this is a huge shift in terms of how you think about continuous delivery, right? The clusters themselves, they are aware of state changes, and they do their own state management, instead of having this imperative thing like a CI job which connects to them. Now, how is a GitOps delivery pipeline? How it looks like? You have, let's say, a namespace, a Kubernetes service, and a Kubernetes deployment in your app repo. Flux connects to it and applies it on the cluster for you. If you change the deployment, let's say you do a release of your app and you build a new container, Flux can monitor your container registry, see that, okay, there is a new app version to be deployed. And what Flux does, it goes to the repo and commits the change. It changes for you the deployment YAML and sets there the new version. Then Flux pulls the change inside the cluster and applies the app. Now, let's say you have Linkerd installed on the cluster, the new version gets rolled out. Linkerd also comes with Prometheus, so you have a lot of insight of what's going on with the new version of your app, if it's failing or not. You can, inspect it through the Linkerd dashboard. You have Grafana dashboards. You can set up Prometheus with Alert Manager. So you'll be aware that something is wrong with your app, and then you have to decide, based on all these metrics and dashboards, after you look at them, decide if you want to roll back or not. And in a GitOps world, what's a rollback? You basically go to your Git repo and set another version, maybe the previous one. You can also do a Git rollback of the last commit, and then Flux will roll back the app in the cluster. But if you have like many apps, this is quite a challenging process, right? You have to first detect that something is wrong, then take the decision to roll back, and so on. So that means you have to have 24 hours people that are looking at dashboards, that are receiving alerts. You have to have an on-call team, proper on-call team to do that. And even if you have an on-call team, if you have like many apps, it's still a lot of manual process involved. So how can we improve this? Deploy my app, look at metrics, see dashboards, and decide if we should roll back or not. And here we introduce Flagger in the pipeline, right? Instead of letting Flux applying directly the new version that's in Git, Flux hands over the release process to Flagger. And what this happened is that Flagger, instead of replacing the old version with the new version, spins the new version in parallel with the old one. So you'll have two versions running at the same time. And this is called canary release. Then it uses Linkerd to route traffic between the two versions. And it can route 1%, 2%, and so on. It can do a progressive rollout of the traffic to the new version. And then you can tell Flagger which metrics to look into Prometheus and determine if the new version is okay to be fully rolled out or if Flagger needs to undo it. So what this gives us is better confidence in our pipeline. We can make mistakes. We can do a faulty release. Something, an automation like Flagger, will detect that and will quickly roll back and it will let me know. So I don't have to wake up at night and undo my changes, or on a Friday evening. Flagger will do it for me. And when I'm available, then I will go inspect, look over the dashboard, determine what's the actual error, and do a fix and bump the version in Git. Here in the diagram, we also have Nginx here as an ingress, and we'll be using Nginx in our demo. But for Linkerd, works with a lot of ingress controllers, Ambassador, Contour, and hopefully in the future, the new Envoy gateway. The idea is if you want to drive traffic inside your mesh to reach your apps, you need an ingress controller. Linkerd does not come with this piece of infrastructure for networking. Linkerd only deals with traffic inside your cluster. Okay, so a bit of a deep dive into a canary release. When we first deploy an app, let's say it's version 1, this gets deployed automatically by Flagger. So it doesn't do anything. It sees, oh, there is a new app, and it initializes it and it lets it run. Then when Flux changes the app version, let's say switches to version 2, what Flagger does, scales that new deployment to one replica and starts routing some of the traffic to it. Then it offloads the replica setting to Kubernetes horizontal pod autoscaler. So the more traffic your application will receive, the horizontal pod autoscaler, if it's configured with Linkerd metrics, you can do the horizontal pod autoscaling based on the number of requests or the latency, right? So you have a good way of scaling your app, not just by CPU and memory usage. And that's also a great advantage of having a service mesh inside your cluster. The idea that you can scale based on better metrics than just memory or CPU usage. You scale based on the actual usage of your app, which can be I don't know, a gRPC connection or the number of HTTP requests and so on. So while the horizontal pod autoscaler scales V1, it also can scale down version 2. So you don't run more pods that is necessary to serve all the traffic. And while Flagger does that, it reads periodically from Prometheus and checks if version 2 fits the service level objectives. And you can set service level objectives like, the new version that I'm rolling out, if it returns HTTP 500 errors and is more than 2% of all the requests, that's no good. It will break our SLA, so roll it back. Or if the new version responds, it's okay, it responds to the user, but the latency of that response, it takes a very long time, hundreds of milliseconds or tens of seconds. Then maybe you have an SLA for the response time, so you can configure Flagger, to roll back that faulty version. If we assume everything goes fine, what Flagger does in the end, it completely replaces all the replicas at the new version, version 2, then it shuts down the canary instances. Besides the canary release with progressive traffic shifting, Flagger supports other deployment strategies. For example, A/B testing based on HTTP headers and cookies, which are almost required for front-end apps. If you serve HTML, JavaScript, and your API, you need some kind of session affinity, and you need to pin some portion of your users on the new version while all the others have to stay on the old version. Otherwise, they will get, the HTML from the new version and the JavaScript from the older one, and that will mess up all things. From this list, Linkerd supports canary lists with progressive traffic shifting. If you want to do A/B testing, we need to get an ingress controller in there and set up the header routing at the ingress level. But Flagger will still use the Linkerd metrics, so you don't have to instrument your ingress controller. We can rely on Linkerd for all of those. Another deployment strategy is blue-green. You can do traffic mirroring or traffic switch, the usual blue-green deployment. Traffic mirroring is not yet supported by Linkerd, but I hope in the future Linkerd will also support this type of traffic management. The idea is that traffic mirroring is great because you don't expose users at all to the new version until the new version, you decide that the new version works great. The issue is that if you duplicate the traffic, and I don't know, if you are deploying an app which does, I don't know, bank transaction or something, people will pay twice, or bad things will happen. So you can only use traffic mirroring for apps which expose idempotent APIs, where no matter how many times you call an endpoint, the state remains the same. And blue-green, the classic one with traffic switch, works great for legacy apps, stateful applications, and so on. Cut to the demo part. Going to switch to my console. So
As we all pray to the demo gods that it works well.
Let's hope so. Yeah, I have a cluster here. It's on GKE with 3 nodes. If I do Flux version, so I have the Flux CLI installed, will tell me that there is no Flux deployed on my cluster. Now on GitHub, I have created a Git repo which holds the desired state for a cluster which has Nginx, Linkerd, Flagger, a bunch of stuff, and also a front-end app and a back-end app. So the idea here is that you want to spin up a new cluster and you want to have Linkerd and everything set up there. Right? In a normal way, you'll have to run, you install Linkerd using the Linkerd CLI or the Helm charts. Then you have to install the Linkerd visualization and plugins. So you have to use the Helm charts for that or the CLI plugin. Then you have to install Ingress Nginx. You have to make sure that Linkerd is running before you can install Nginx, because Nginx must run inside the mesh. Right? So you have to fetch the Helm chart for that, run a Helm install, and so on. So there are a bunch of commands if you need to do this from scratch. By adopting GitOps, all you have to do is define how your cluster looks like, what things should be deployed. You place those YAMLs in your Git repo, and then with a single command, which is called Flux Bootstrap, everything will spin up automatically. So this simplifies a lot, creating clusters from scratch, duplicating clusters, creating new environments, and so on. And Flux, the CLI, has a command called Flux Bootstrap, which looks like this. This is a special command for GitHub. There is also a Bootstrap for GitLab or a Bitbucket and so on. The idea here is that I have exported in my environment variable my GitHub token. So the CLI now can talk to the GitHub API as it in my name, right? And at the Flux Bootstrap, I'm telling, hey, I want to set up this cluster, and peer Flux, install Flux on the cluster and peer it with this repository at this branch. So if I'm going to run this command, what will happen is Flux connects to GitHub, it sees, oh, there is a repo there, then it commits in that repo all the Flux definitions. The idea is that after you run Flux Bootstrap, you don't have to connect to the cluster anymore. So how are you going to upgrade Flux if you need to run this command every time? Well, Flux stores its definition inside the Git repo. So if you need to update Flux or Linkerd or any other component, you just change the manifest in the repo, and Flux can upgrade itself along with everything on the cluster. So Flux has now installed all the components. And it also has set up an SSH key on GitHub. So now if we go to our repo here and we go to settings and you go to deploy keys, we see that Flux, the CLI, has created this deploy key for me, which is unique for this particular cluster. And inside the cluster, there is the SSH private key. So every time you do a bootstrap, if I want to use this repository for multiple clusters, each cluster will have its unique key. If I want to disconnect Flux from the repo, I just delete the key and that's it. Right? So all this automation is done from the CLI. Now let's see what Flux has actually did in my repo. See here a commit add Flux sync manifests. And what Flux did, created a bunch of objects, and it has created two Flux custom resources. One is the Git repository. This is how you tell Flux, how you define sources in Flux, and we tell Flux, hey, there is a Git repo here. Here is the URL, the secret, the branch, and so on. And another object, which is called the customization, which does the actual apply of all the things on the cluster. And after I run this command, I have all these things in my repo, and I can use the command line to see, for example, all my Helm releases. So I have a bunch of Helm releases. One of the Helm releases is called with GitOps, and I'm going to connect to the with GitOps UI to show you more what Flux is doing. First, I'm going to start port forward. I haven't exposed the with GitOps UI, neither the Linkerd UI through the ingress controller, only the demo app. So I need to port forward to it, but you can also expose them through ingress. And now if I'm going here and access this address, I should see the with GitOps UI. With GitOps allows you to set up an admin password, user and password, but for production systems, you should configure this UI to log in with an OEDC provider. For example, allowing only certain members in certain GitHub groups to see certain namespaces or things inside your cluster. So you can use OEDC for GitHub, Google, Microsoft, and others in order to manage the authentication. So I'm logged in. Now should make this bigger. Okay, so here are the things that have been deployed by Flux in my cluster, and let's look at the Linkerd customization. So let's see how I've set up Linkerd with Flux. First, I have created a cert manager deployment. Why? Because I want for the Linkerd certificates to be rotated every 24 hours. And Linkerd by default does not do that, but we can use cert manager to generate the certificate that Linkerd uses to create MTLS inside the mesh. And we can tell cert manager, recreate this, rotate this key every couple of hours or minutes, right? So first, I have to deploy cert manager. I can't deploy Linkerd at the same time with cert manager because the Linkerd installation needs those certificates. So I'm creating this dependency tree. I'm telling Flux, first configure cert manager, create the CA certificate for Linkerd, then deploy Linkerd, and then Nginx ingress. In parallel, you can also deploy Flagger because there is no dependency between Flagger and Nginx, but both Nginx and Flagger must run inside the service mesh. So that's why both things depend on Linkerd. And finally, deploy all my apps when everything in the infrastructure part is set up. Now, if I go to Linkerd, let's see.
Hey, Stefan, can I jump
Yeah.
in for a moment? We have a
Sure.
question about how exactly you defined that sequence between your customizations. Is that something that would be good to talk about right now, or should we
Sure.
save that one for later?
No, we can talk about it. So these custom objects, which are called Flux customizations, are of course defined in the Git repo. So if I go to Linkerd infrastructure, I have here all my infrastructure items, set manager, ingress, Linkerd, and so on. Now, if I go into the infrastructure YAML where all these customizations are defined, we see, for example, that the Linkerd one has a property called depends on, and that depends on cert manager. Then ingress Nginx depends on Linkerd. So with the depends on key, you can create this dependency tree, and you can have more than one dependency. For example, if you look at the apps, the thing that deploys all the apps on the cluster, they depend on two things, on Flagger and ingress Nginx. Why? Because I want to do the canary release using Flagger, so I have the canary custom resource in my app definitions. I can't apply the apps on the cluster if Flagger is not installed because it needs that custom resource definition. Then when Flagger sees the app, it creates ingress objects. So it needs Nginx to be there, right? So with depends on, it's a way of you to tell Flux, hey, install things in a particular order, and most importantly, upgrade things in also that particular order. So for example, if you have an application that requires database changes, we can use the depends on keyword and tell Flux first run the jobs that are doing the database migration, then apply the new version of your app, and finally run another job that does the end-to-end test or stuff like that. So it depends on, it's useful to spin up cluster from scratch using service meshes and so on, which require, no matter the service mesh, this type of deployment where things depend on each other is required due to the sidecars that must be placed everywhere, but also for your app delivery as well. Okay,
Thanks.
so
we actually have several other questions, but I think they're things that will do well to hold until the end. So thanks for tackling that one. Let
me show one more thing, how Linkerd looks like from a Flux perspective. So Linkerd is the Linkerd customization applies several Linkerd Helm releases. One of the most important one is the control plane, but also here we need a certain dependency tree in order to deploy Linkerd correctly. And here are dependencies, this time between Helm releases. So Flux also supports this stuff. So first Flux has to install the Linkerd CRDs. Then it installs the control plane. Once the control plane is healthy, that means, so Flux has a way to check if a deployment is ready. That means the Linkerd injection webhook, the controller that injects the Linkerd sidecar everywhere, is operational. And only then we can deploy in parallel Linkerd Viz, which comes with the Linkerd dashboard, Prometheus, Grafana, and so on, and the Linkerd SMI extension, which enables Linkerd to do traffic switching, which Flagger needs, right? So this is how we orchestrate the Linkerd setup. Another thing around Helm releases, when you do Helm releases with Flux, you can pin a particular version. Like when you do a Helm install, you can say I want to install 1.9.5, but also Flux supports giving it Semver expressions. So how I install Linkerd here, I'm telling Flux install the latest 1.x version. So what Flux did, it went to the Linkerd Helm repository and download the latest version and has installed it. Let's say tomorrow Linkerd does a new release, a patch release of the control plane. Flux every half an hour checks the upstream, the Linkerd official Helm repository for new versions. If it finds one that matches the Semver expression, it will automatically upgrade your cluster to the new Linkerd version. This is how you can fully automate, for example, CV fixes or critical bug fixes on your cluster. You can, for example, say on the staging cluster, I always want to run the latest Linkerd version, and on the production cluster, only the latest patch version and so on. And then you can promote Linkerd major release from one cluster to another. Okay, so this is about how Flux orchestrates infrastructure. Let's see how now Flagger can do a release of an app. So I have here in my cluster, I have deployed two apps. One is in the front-end namespace and one is in the backend namespace. The front-end one, it's exposed through an ingress controller, runs inside the service mesh, and the backend one runs only inside the service mesh, is not exposed. So let's say I want to do a deployment of a new version of my front-end app. What I can do is I'm going here into my app definition in Git, go to the front-end definition, and I have here the Flux customization. And one thing that Flux allows you to do is it allows you to patch container images inside deployments, which are coming from other repos. And you can, as I said, fully automate that. So instead of manually bumping the version here, you can tell Flux to do it. But for this demo, I'm going to bump the version. It was 6.2.0, and I want to change this to 6.2.1. But let's see the actual app that's running on the cluster. It should be available. We can query the cluster for all the canaries, which is the Flagger custom resource. And we see that Flagger has initialized both the backend and the front end. Let's access the front end. I'm using my LB IP here. So this is Opera, one browser. I'm going to also open the same app in Firefox. Right, so no matter from which client I'm accessing the app, I see the same version, and we see exactly what was the name of the pod that serves this traffic. And because there are two instances, it flips from one pod to another. So all users now are on 6.2.0. Now I'm doing a new release and I'm bumping the version to 2.1, and I'm going to commit this change on the cluster. I committed to the wrong branch. 1 second. I have to do it on the test branch because that's where I bootstrap the cluster. Going again here. And here is the place where I can bump it. Okay, so I have committed the change. What happens now? Flux periodically pulls the Git repo and checks for changes. And for example, we can let's use with GitOps UI. We have here sources, and under sources, we have all these, sources defined. But my my actual app is a Git repository. That's where I have defined them, and I have here the front end. And I'm look here at the front end, and it said last updated 30 minutes ago. I could click sync here and tell Flux, hey, go and check now. Don't wait 5 minutes for this. Go and check now if there is a new version of my app. I can do the same thing from the command line using the reconcile function. But anyway, it has already started, and you can see now that because I made a change to the whole cluster state, I changed one file. What Flux does now, because there is a change, it goes through the dependencies again, right? So it checks, is there a change in set manager? No, it's not. Is there a change in Linkerd? No, it's not. Is there any change in apps? It is. So that's only the change that you actually applied on a cluster. And is that this Flux uses Kubernetes server-side applied dry run, where it asks the cluster, compare this desired state with what you have in etcd. Are there any changes? And Kubernetes will tell it if there are changes, and then Flux will apply only those manifests, only those objects which have changes, right? In order to optimize the speed of delivery. So now,
can I jump in with another quick question here? This would be exactly the same process if you wanted to roll back instead of forward, right? You just edit the version number to an earlier one, and it's the same if it's a Helm thing versus a Git thing.
Yes, doesn't really matter. It's the versioning works the same everywhere. It's great to use Semver for everything, but you can also use for Git repos, you can use branches, you can switch from one branch to another, or come up with your own versioning system. So what has happened, right? I have set up the new version. This client is on the old one, but this one, Firefox, is on the new version. So now all the Firefox users have been routed through Nginx, through the service mesh, through Linkerd, back to the new version. And if we want to see this, how the traffic flows, so now what Flagger does, it has started a load test and verifies if the new version 6.2.1 is in parameters. So I can now go and do a pour forward to get the Linkerd dashboard running. And let's look at the Linkerd dashboard. Linkerd has a similar interface to with GitOps. It shows you the namespaces, the deployments that are running, but it gives you this insight into traffic, and it's more about how your apps, how the traffic goes from one app to another, and if everything is it's successful or if there are errors. And for example, we can look at ingress Nginx here at the deployment, and we can see that from Nginx, traffic goes to the pod info primary, which is this one. Oh, it's already done. It was too fast. Anyway, the traffic goes through both versions. And at some point, what will happen is, because the rollout was successful, the new version didn't had any kind of errors, and Linkerd also shows this success rate here. Also, Flagger can look at it. It's all reported in Prometheus. Once the new version has been tested and it was successful, the primary deployment, that's how Flagger names everything, has been upgraded to the new version, and then the canary, as you can see now, is being scaled out. There is no need to test anymore. I'm going to close that deployment, scale it to 0, and run only the primary for the new version. And now, as you've seen, both instances are at the same version. Now, next week, we are going to do a deep dive, a workshop where everybody can, use this setup and play around with it. And during the workshop, we will also simulate errors. We'll call specific endpoints of podinfo, which will error out with 500 errors, and we are going to see how Flagger rolls back the change and switches all users to the old version because the new one has failed. And we can also simulate latency and see how Flagger reacts, and also how you can, visualize everything with the Linkerd dashboard. And I think that was the demo for today. Going back to the presentation. Going to say a few words about Weave GitOps Enterprise and progressive delivery. So if you switch to Weave GitOps Enterprise from the open source edition, you have a dedicated, UI for monitoring the delivery process with Flagger and canaries, and it shows different things than Linkerd. It shows the versions, which versions are deployed, and so on. And Linkerd shows how traffic goes, and that's one of the things that Weave GitOps Enterprise has. Switching next to Flynn.
Similar sort of thing. We also have an enterprise product called Buoyant Cloud, which is a lot like the Linkerd Viz dashboard, but much more advanced. There's a lot of other stuff that it can show you, and it can also do really nice things like handle automated Linkerd updates for you and certificate management and a bunch of things like that. Be happy to have you take a look at that, which you can do by looking at buoyant.io/demo.
But you still run the control plane on your cluster, right?
Yes, we do. There's Buoyant Cloud does not ever go and reach into your cluster and mess around with things. It's a management interface that allows you to tweak things on the cluster, but it never goes in and does things behind your back. So
the certificate that, for example, cert manager in my case was generated inside the cluster, that cert stays there.
It stays in the cluster. Yeah, it's an administration tool, not a security risk.
Great.
Yeah. Q&A, we do have some questions. Let me just run through these at the top, from the top. And so I think most of these are going to be fairly quick answers. And I also imagine that, so for example, if you feel like something needs a longer answer and it's dealing with Linkerd, you can find me on the Linkerd slack.linkerd.io. Stefan, is there a similar place where folks can go?
Yes,
if they have
the CNCF Slack, there is a channel for Flux, a channel for Flagger called Flagger, and on the Weaveworks Slack, there is a channel for Weave GitOps, the open source edition, where people can ask questions there.
Great. And you can also find me as Flynn on the CNCF Slack as well. Let's see. So first question then, we had a question about, is there a quick summary of differences between Flux and Argo and Spinnaker? Recognizing that that could be a very long answer, but just a quick take.
Yeah, Flux is better. That's my quick take.
Absolutely.
Of course. The differences are, there are many, many differences. For example, Flux is the only tool out there that has a fully integrated Helm experience. We use the Helm SDK inside Flux. We have a dedicated controller and so on. So if you deploy things with Helm, you'll probably want to choose Flux over the others. I'm not sure how Spinnaker works with Helm, if it even does. But I'm guessing, like Argo, we can use the Helm template function and then do a qcut apply of the resulting YAML. Also, what we have recently, Weaveworks has recently done, they have created a Flux extension called the Terraform controller. So you can apply all the GitOps principles to Terraform, and you can provision more things outside your cluster using Flux. I don't think Argo or the others have such a feature. One of the things that set us apart in the past was the fact that even Flux has these advanced capabilities. People choose Argo because Argo is simpler to deal with because it has a UI, right? As I shown today, there is a great UI made for Flux, with GitOps, and so that major difference is no longer there.
Yeah, GitOps looks pretty cool on that front, actually. Looking forward to seeing how that evolves. Let's see, we had a question about using Flagger with Knative. Is that a thing?
No, there is
Okay.
issue for that. Sanskar, which is a maintainer of Flagger, he looked into Knative and he talked to the Knative team, and I think there is a way forward to add Knative support to Flagger. When that will happen, when Sanskar will have time for it. We don't really know.
Well, and I mean, the other part there is that Flagger is open source, right? So presumably y'all would be open to donated code there too. So
sure.
Okay. Is the circuit breaking pattern supported? I'm not sure if that's enough context there, but is that a question you can answer?
I don't think Linkerd supports that currently, but my hint is then when Linkerd will adopt the gateway API, then we'll come with backup retries.
Okay.
And all of that stuff.
And I can say that Linkerd is actively working on that, but I'm not going to commit to a date or a version number for that support in Linkerd right now. But yeah, we will hopefully, let's try to make sure we talk a little bit more about that in the workshop coming up next month.
But what I've seen for sure is that circuit breaking is on the roadmap somewhere in the Linkerd.
Yeah, it's a common request. Yeah. Okay. Can you use on-prem GitHub or GitLab Enterprise, or must you use, the cloud GitHub for this stuff?
You can use any Git server. So there is a Flux bootstrap Git command that uses your SSH local key or your SSH agent. But especially for GitLab Enterprise and GitHub Enterprise, we support the same command. So if you run Flux bootstrap GitHub and you give it a different, your enterprise URL and your token, it will do the same stuff as on github.com or gitlab.com. So those are fully supported.
Great. Excuse me. Can the Flux keys be given a time to live?
The Flux keys have a time to live if you refer to the SSH keys, I'm guessing. So when you create a GitHub personal access token, that token expires. And because Flux, the CLI, generates the SSH key using the token, the moment your token expires, the SSH key expires. This is a great feature of GitHub. I think GitLab does the same stuff. Bitbucket does the same stuff. Azure DevOps, and so on. So basically, when your token expires, you have to regenerate the secret on your own or rerun Flux Bootstrap with the new token, and the Flux will rotate the key inside the cluster. But yes, it definitely expires if you run Bootstrap with a token that has an expiry date. If you run it with a token that has no expiry, then you can create, I don't know, some automation with GitHub Action and delete the public key from there and rerun Bootstrap in an automated way to rotate it.
Seems like it's probably better to use keys that have an expiry date.
Yeah, for sure.
Yeah. In your setup here, if something goes wrong installing Linkerd so that the Linkerd installation fails in the beginning, then what all is going to get rolled back at that point? I mean, presumably everything in the Linkerd dependency will get unrolled, but like, would the application also get not installed? How does that stuff work?
So there are two failure cases. A failure is at install time when you bootstrap the cluster, right? When it's nothing on the cluster. If Linkerd fails, there will be no Nginx deployment, no Flagger deployment, definitely no apps, because it goes
So everything
through
downstream of, yeah.
But let's say you upgrade Linkerd and the Linkerd upgrade fails. You can configure Flux Helm controller to automatically do a rollback of the Linkerd Helm chart to the previous version. So all other changes will still be applied as long as Linkerd is functional. Now, I don't know, maybe there is a case where the upgrade goes so bad that, Linkerd itself is broken. And then what Flux will do, Flux can alert you on Slack, Microsoft Teams, or whatever. Hey, this Helm release upgrade failed. This is the error this is how it error out, go and fix it. But if you use the automatic rollback of Helm releases, Flux will continue to work on the older version, but it will never roll back something if a dependency fails, right? It only rolls back the actual thing that failed.
Makes sense. Can you do dependencies between different, like between a Git customization or a Helm chart or whatever? Did that question make any sense? I don't know the right thing to call these.
It makes. So you can, like everything on the cluster is applied through a Flux customization.
Right.
Even a Helm release. A Helm release is just another object in the repo. What applies it are Flux customizations.
Got
so
it. That's the terminology I was looking for.
Yeah, you can just wrap things in a customization and move it from one customization to another to create all these layers. Like I did there is an infrastructure layer, which has, Cert Manager in its own customization and Helm release. Then Linkerd has one customization and 4 Helm releases, because that's how Linkerd works, and it has dependencies between them. But the Flux API allows only dependencies between the same kinds. You can't depend directly from a customization to a Helm release. But if that Helm release is applied by something, and it surely is, then you can use that top level object to create a dependency tree.
Got it. So I think what I'm hearing here is the kind of Flux customization doesn't much matter, but it does have to be something that's been pulled into Flux as a customization.
Yeah.
Cool.
Yeah.
Okay.
You can apply anything.
Yeah. I think we already answered this one, but just to make sure, if you want to roll back something that's being installed via a Helm chart, then it's not so much that you try to do a Helm rollback, you would go and edit the version number and do a git push and let Flux handle it for you, right?
No. Well, you can do that manually, but Flux Helm release has a rollback specification where you can tell Flux to automatically roll back the Helm release to the previous version. And you can also tell Flux how many times it tries to roll back, because if you deploy stateful sets, a rollback could also fail. So you can tell Flux, hey, we tried the rollback a couple of times, maybe it doesn't work, go to the previous version and so on. And Flux will do its best. But usually if you are dealing with not infrastructure items like Linkerd and so on, if you are dealing with app deployments, it's better to use Flagger and rely on Flagger rollback than just a Helm release rollback. Why? Because when you use Helm, and how can you determine the healthiness of the new version? You just look at the readiness probes, the readiness probes in Kubernetes, right? But those don't actually tell you if the app fails for the end user, right?
Yeah.
And that's where Flagger and Linkerd come into play, where you have that insight in what actually people receive. Like the app rolls out great, but if everybody gets a 500 error, then it's not actually working, right? So for infrastructure items, you can definitely enable rollback at the Helm release level, but for front-end apps, user-facing apps, APIs, it is best to use a canary release and do the traffic switch.
I think I was reading the question more as if you've decided, oh, I'm running X version and now I want to go and run an earlier version, then
You can definitely do that. Yes.
Yeah.
Go in the Git repo and pin it to an older
Right.
version.
And Flagger, when it's doing its thing, I should just phrase this as a question. Do Flagger and Flux ever do commits to your Git repo for you, or are they
No.
solely read-only?
No, so Flux only does commits to your repo based on policies that apply to container images. If you push a new container image, it will bump the version for you. The
Gotcha.
rollback part is done in the cluster, then Flux or Flagger will alert you. It both support alerting on a bunch of systems. And that should be treated as a production incident, and you should go there, inspect what's going on, then decide, do I want to roll back everything in Git, or I want to go forward, fix the thing, and bump the version, the version to a newer one. Usually, you want to go forward, not backwards. Rollback is something that's temporary, and it gives you confidence that, hey, I don't have to fix it now. I can, do my Friday evening and I'll fix it Monday. But you still have to fix it, right? It's not something that will be permanently rolled back.
Yeah, rolling forward is safer in general. Okay, thanks. Question here, do Flagger and Linkerd need to share the same Prometheus instance?
Yes.
That's what I thought.
So Flagger relies on the metrics that the Linkerd proxy provides. So you have to tell Flagger, you can tell Flagger in a bunch of ways. When you install Flagger, you can tell it, hey, here is the Prometheus instance you should look for. But maybe you have, I don't know, several instances, several Prometheus instances on your cluster that are doing different things. You can also set for each canary a different Prometheus endpoint. But the gist is that Flagger does not generate these metrics. It relies on the service mesh generated, and Flagger reads them. So yes, you need to connect Flagger to Prometheus. Now, you can set up the Prometheus that's deployed by Linkerd to send all these metrics to a different instance, I don't know, a managed instance and so on, because the Prometheus that comes with Linkerd, that data is ephemeral. You can't store there terabytes of data. Prometheus itself is not made for long-term storage. So you can set Prometheus to write all these metrics to something else like Cortex or, I don't know, AWS, Google. Everybody has some managed Prometheus offering. And you can configure the Linkerd Prometheus to send the data there. And you can connect Flagger to the AWS Cortex instance, for example, and Flagger can read the data from there. Doesn't really matter. It doesn't have to be the same instance. The data has to be the same. And to elaborate on that a little bit, please don't use the Prometheus that comes in with Linkerd for long-term production use. If that ends up restarting, then yes, your chronological metrics data go away. If you do a Linkerd install or Linkerd viz install, then it will bring a Prometheus in, but that's pretty much just for demos. Don't rely on that for production work. Last question. Hey Flynn, will you remove traffic split from Viz soon? Yeah, it's a thing we're working on. What's going on here is that the Viz dashboard has a traffic split tab on the left that does not work in the current version of Linkerd. We know about it. It's actively being worked on. In the short term, the tab is probably going to go away. And in the longer term, we have to reintroduce proper ways of visualizing traffic splits and all that. So yeah. So yeah, we're working on it. Again, they don't let me talk about dates and things like that, but it's on the roadmap. We're working on it. And that's it for the questions, unless anybody has anything else at the last minute. But Stefan, I think we have a couple more slides to go through as we, Yeah, we have some links here. We're going to share the presentation later on around progressive delivery with GitOps and more web binaries that we do. And from the Buoyant side,
We've got the next
the
next
next-
part of this, the real world GitOps with Flagger and Linkerd, where we're going to be, first off, this is a workshop coming up next month on February 16th, rather than just going through the demo. We're going to prep all this stuff ahead of time so you can follow along live, and we would encourage you to do so. So we're going to be getting into some more of the details and some more of the gotchas, and yeah. You can sign up for that at buoyant.io/SMA. Hoping to see everybody there. And I think we had one more slide. Yes. So we had the one more slide for Linkerd Day in Amsterdam at KubeCon, the inaugural day 0 event, Linkerd Day. We'd love to see everybody there. There's a link that I believe will be posted. There we go. There is a link posted about where you can go to submit CFP responses. We are really hoping to get a bunch of interesting papers focusing on sort of end user use cases of Linkerd, so that we can talk about how all this stuff works in the real world, rather than just having a bunch of vendors pitching stuff. So again, hope to see everybody there. And was that it, or did we have any other slides here?
I think that's it.
I think that's it. Thanks to everybody for joining.
Yeah.
Thank
Thanks,
you so
everybody.
much, Flynn and Stefan. That was brilliant. So yes, we will send the recording and the slides over to you all tomorrow. So check out your inboxes, and thank you everyone for staying on. I know we've run over, but it was a very good session. So thank you everyone. And
Thanks
yeah,
much.
hopefully see you at the workshop. Bye-bye.